Thank you, NIIT and Stackroot for inviting me over here. And it's a privilege actually talking alongside so many stalwarts, right? To even have this time to talk about some of the experiences that we had within the organization on the work that we are doing generally on the IoT side. Uh, so let me just figure out. Okay. So as an organization, so we have a couple of use cases that we have worked on the IoT front, and I just wanted to take this time to talk about one of the use cases that we worked with one of the a large leading energy company, renewable energy company. And how did we kind of work with them to build a basic foundational data implementation on AWS as for their IoT analytics, and also to help them in some of the challenges that they were facing for predictive maintenance and some other ML AI related model building and so on and so forth. So before I actually dive into the architecture or the solution or the basic understanding around it, I just wanted to talk about a few terms that we generally kind of see in our IoT world. So this side, this primarily, if you look at most of the heavy industry, I would say companies, they have large, big size factories, as well as there are multiple, I would say, machineries which requires a lot of, which actually creates a lot of data from the sensors, and which goes into this a couple of a couple of items, sorry, the SCADA data acquisition, that supervisory control and data acquisition platform. So I'll just talk a little bit about these 4 items that I have just put together. So PLC is your the front end units which is connected to various machineries and systems from where we control different devices. And you must have seen the movies, or I guess some of the documentaries. We see a lot of factory operators operating them. They are distributed. They are basically in their direct in the locations where they are being operated on. Then we have SCADA, which is a centralized a system on which this software is installed, which controls or understands the or acquires all the data. And then these 2 platforms basically communicate with each other with a different messaging architecture, which is built on OPC UA. Just as general structure, very I would say simplified version of what we see. And then tag databases are just the databases where which is generally inside or stored inside the unit, which is where the SCADA is running. So we store all the data over there. Whatever data or the sensors actually generate comes into the tag databases. Now, the challenges that we have in this entire setup is mostly, this entire setup is disconnected from the larger ecosystem or data ecosystem of the organization. Most of the times they kind of work in silos. There is no insight that is generated out of it, and that's the second problem. It's not connected to the, as I said, data ecosystem to build a truly connected, I would say, fully integrated ecosystem to which can help then to build some models and generate some AI insights out of it. Then third is scalability and maintenance. Generally, there are challenges when we talk about the maintenance of these platforms in SCADA. Because it depends on the operating system in which it is running. There are patches based on which it has to be upgraded, and there is a lot of customization that needs. And generally, they are not very easy when it comes to different sets of equipments and what kind of equipment support system do you have. Based on that, you'll have to upgrade the SCADA system itself, and every time there is an upgrade of the operating system, there would be a different patch available. So there's a large problem over there to keep maintaining this system itself. Then device interconnectivity and security are also some of the challenges that are present in this entire ecosystem. Now, as I earlier said, right, the heavy industry, or you talk about oil and petroleum, or mining industry, or any other those sort of industries, SCADA, PLC, these legacy systems are heavily integrated within their ecosystem. So it's very difficult to get them replaced by something new, cutting edge, because it's a large investment. It's very difficult to even create or basically invest, or companies do not find a reason for that, or it's very difficult for them to move since the size of the organization is so big. So we kind of worked on the first two pieces of the challenge, because all the three other pieces were more of an organizational decision, and which basically kind of stopped us from truly completely overhauling the entire system. So we worked on disconnected ecosystem and the lack of data insights. So the objective is simple. We needed to bring in data from these. In this case, we were working with the, as I said, renewable energy company. So we had wind farms, and we had battery systems, large battery farms as well, from where the sensor data and obviously the weather data, as well as the turbine information which was coming in to us. And the idea was to deal with basically the challenges around predictive maintenance. There are challenges around analyzing the long-term use cases that we can leverage from the data that we are collecting. Trend analysis to visualize, kind of see what other long-term issues do we see in a particular maybe in a particular setup, and also how can we mitigate them ahead of time. So if you look at this, the first three phases, or I would say categories, here is on-premise, and the rest of it is on AWS cloud. So these three here, where we're talking about battery systems, where we are connecting all the sensors with the SCADA system, these are all operated as well as managed by the organization itself. And then we have implemented something called this AWS's solution, which is called IOT Greengrass, which is another software which goes in and installs into your SCADA system, which ultimately can connect you to AWS directly. So that's IoT Core, which works as a gateway for the data to move to the AWS cloud. And then from that point onwards, it's basically all AWS related or services that we utilized. We have KDA, which is Kinesis Data Analytics, and we used a simple, actually quite interesting tool. Interesting the way that we implemented it is Drools. So Drools is a Java-based open source rule engine. So rather than writing out the rules for any kind of issues to identify through the streaming data that we are getting, embedded inside the code, we used rules where you have the capability to kind of decouple the code and the rules from each other. So now you actually, without changing the code, you can customize your rules, and based on that, the alerts and everything will kind of move and be, will be used for can be used for notification purposes. And then this AWS Kinesis Firehose and S3 buckets and Redshift. This is more of a data storage and streaming space where we are storing the data. Redshift is, as you might already be aware of, more of a data warehouse solution. Athena is again S3 based, Hive based database. And then we have TimeStream, which is again AWS specific solution for time stream data, more of giving insights on how the data has trended over time. And then this all is ultimately connected to different various consumption layer or insights and alerts. So you have SQL-based data access or QuickSight dashboards and also alerts generated out of them. So this is the entire ecosystem that we built to just get the data inside into a platform where you can consume it and basically make decisions out of it. So there are AWS QuickSight real-time dashboards, and also from the Redshift SQL-based data access, and from there ML models and AI, AI-driven models can be trained, and based on that, certain decisions can be made automatically. So here, some of the use cases that we have already implemented, and in some cases we are also working on certain use cases either within this this particular engagement or some of the other ones based on the learning that we got from here. So here, the major problem statement or what we tackled was more of from the diagnostic and predictive maintenance. So the predictive maintenance is where we are, based on the data that we are getting, how you can identify the challenges or the issues a particular device is going through, some of the patterns, reading those patterns, and then based on that, the system can automatically figure out how or when a particular maintenance can or should be scheduled, or is there any to reduce outage or interruption. So this is more of a proactive measure that can be utilized. And we did implement it for some of the hardwares or some of the components that we were working with. Some of the other I'm not going to go through all the use cases that we work, but some of the use cases also to improve your customer service, also your some of the consumer part recommendation is something that was quite interesting that we worked on one of the small engagements where we're trying to forecast what critical parts or needs to be replaced. Based on the inventory and based on the challenges or the issues that are going in inside any in a supply chain, things like those. So so this is about the entire architecture and solution for the IoT, one of the IoT use cases that we worked on. So if you have any questions, please go ahead. Yes.
Framework that you use to apply to this particular problem to give them specific
yes.
alerts and
that's correct. And right. So right now, the way if one of the conversations initially during the talks, right, was about IoT and how IoT is obviously is something which requires a lot of work, but it has a tremendous potential. Right now, this truly connected ecosystem is not yet there across different industries. So there's a lot of work that has to be done, and this is a very basic kind of implementation of what we would essentially need to do across all the organizations. So one of the important aspect is we would also like to move this this entire legacy system and kind of take this I wouldn't say AWS, but any tool for that matter. If we can move this further along left, then it would be much more easier to get the data out of those sensors, directly from the sensors, and this will help in basically the problems on protocols and the latency and challenges around getting real-time data and batching them. All those kind of challenges we can reduce if we can go further left. But then that will take time.
AWS
No, it has, but it's very difficult because these legacy systems are too deeply rooted within these organizations. So it's very hard to, get them implemented. Yeah. So these sensors are, we haven't used it. It's a sensor which is already implemented or already installed within the customer, basically wind farms and battery systems across those. So we didn't have to deal with the sensor itself because that part was completely done. Yeah, so third box onward is where we actually started our work because by then the data was already available, right? So implementing this IoT Greengrass on their SCADA system is what from where we started. Yeah.
So you assemble a solution by architecting all these pieces.
Yeah.
Which are part of the offerings out of the AWS.
Correct. Yes. Yes, that is correct.
Data security might be the big issue.
Yes, that is there. And data security, see in this case, right, MQTT is one of the protocols that it's a standard protocol that we are supposed to, or that is used across. And data security, again, as I said, if we move further left, right, the data security issues can be addressed in a much better way. Right now, there are complications based on the challenge with the legacy systems and how it interacts with the newer technologies. That's definitely a challenge.
But where does the cybersecurity risk come here? It's a closed system, right?
Well, there are, there could be issues within it won't be directly about security. So moving your data or the sensor data from your sensors to your SCADA, that place is a point where there could be a security challenge. Then SCADA to Greengrass, well, this is the same system, so there wouldn't be any difficulty over there. But we have seen challenges where there is a conversion of messaging protocol that has to happen in between. And that's also a challenge. It's a latency issue as well. And then again, a security because these are all remote locations. So they are not sitting in one place, right? So the data has to move from remote locations into a centralized system. And there is always going to be data in motion security challenge in these cases.
Over public networks.
Yes, in this case, it is not over public network, but that is another point when we do deal with SCADA systems. So SCADA upgrades required internet access for any patchwork, and that's a problem, which again, in this case, Greengrass doesn't need.
So how is this Purdue module kind of being taken care in this use cases?
Sorry?
I says Purdue module is there, right? Where the SCADA works and all these. How is it being taken
So yeah, so I am not an expert on the SCADA system itself.
No,
So
I'm saying that overall, right, the on-premises
correct.
and AWS cloud, right?
Right.
And that there's a Purdue module which is being from the 0 to 1 and up to 5, right? That's where the industrial control system like SCADA works. So how it is being taken care?
So Purdue model, I am not very familiar with that. If you're, maybe I'll have to.
So, okay, what I'm asking, any industrial control system, right, which is working on the remote sites and all this, right? So they work on the basis of the Purdue model. Whatever the security systems is, I think, sir is asking, that is basically that how the system is working and you need to segregate it between the IT and OT.
Yes.
Right?
Right.
So how, in these cases, how it is being considered that? Just want to understand that how it is being considered
So
in these use cases.
In this case, right, the model that you're looking at, we had implemented this within the closed system initially for a pilot project initially.
Okay.
And we have not gone to a detail of the security system or the implementation of that layer in general, or I would say that that's another step that we'll have to take in later on. But that was not the case initially because we did not have the amount of data that we are capturing is also limited at the moment because of the scale in which we are functioning.
That is the challenge is basically is in this entire ecosystem is being facing, because if it
Yes.
that's why that customer is not coming out from that zone and it is not able to take it immediately this is that entire ecosystem for the Purdue module is having the challenges. That's why I want to understand.
Okay.
That one.
Okay.
Thank you.
Thank you. Thank you so very much.
Thank you very much.
Suprakash.